Hi and welcome back. This is class 15 of the series of tutorial. During this class, we are going to talk about all the technical passes that we need to prepare for compositing, such as the shadows or some special lightings and some more AOVs. The first pass we are going to create is the shadow pass, the pass containing all the shadows from the dust onto the environment geometry. Go to the material palette and all the way down into the utility section, select the shadow mat and drag it here. Now go to the material context, cut the material and bring it back into the material network that we created earlier. Now this shadow mat material is to be applied to the geometry which is going to receive the shadows from the dust. Here we have the terrain obviously and the fragments, but maybe also the fence and here the truck. So I'm going to create a geometry here, and inside I'm going to merge all the objects. So once you have all the geometry that you want inside this geometry container, give it some name, like here, LGO, and assign the material, the shadow mat, to it. And then we're going to prepare the mantra pass. So I'm going to set up the obvious offline, but just before we need to go here and force the env geo that we just created. And we also need as a mat the dust. Okay, and here for the lights, I'm going to use the key for now and remove the headlight creation. So I finished the setting of my mantra shadow mat. Here I set the camera and I override the resolution to go half res. I change the output picture here and then I went to the rendering tab and set the sampling to a low quality settings. Then go here to your render. If you select the shadow mat, hit render. And you should not see anything inside the color, okay? Because the shadow mat material is designed to output the shadows inside the alpha. So if you show the alpha here, then you have the shadows. And the first thing we see is that we have a lot of shadows. We have shadows, well, from the dust, we can see it here, almost. But then there's the rest of it. All the material, geometry is casting shadows on itself. And we need to remove that. We want only the shadows from the dust. So go up here, select your geo, and before that, go to the light. And I don't know if you noticed, but in the shadow here, you have shadow selection. And if you look here, you have a tag which is called no shadow, and you have a dash in front of it. This means exclude from the shadow selection all the objects that have this tag. So I'm going to copy this tag, and I'm going to go to the environment here and say category, and I'm going to paste no shadow here. And now if I hit render again, you see that the object is not casting any more shadows on itself, and the only shadow that we have is the one from the dust onto the geometry. So I did another render with frame 100, okay, instead of frame 71, because basically here, this is where my dust is taking the most place and so casting more shadows. And here at frame 100, if I display the alpha, I can start seeing some of the shadow here, but not that much. So go here to the dust shader and increase the density scale, let's say to 50, and launch a new render. And as you can see, the density scale that we changed on the dust shader is affecting the shadow pass here. We have more shadows than before. It's actually brighter here. Now bring this back to 10 that it was before, and here go into the shadow density. And as you may guess, it's going to do exactly the same. And so as you can see, the shadow density is also influencing the result of the shadow mat. Now, if you want your shadow information inside an AOV instead of having it in the alpha, you have to go into the shadow material. And here we are going to create a bind export. Name it with an underscore shadow matte, okay? And here you have to get the alpha because it's the shadow matte is outputting the information in the alpha, and you put it in here, okay? It's a float, so that's correct. And then go to your mantra ROP, and inside the image, go to the extra image plane, and at the bottom here, add one. You cannot select it, so you have to say my shadow matte, okay? It's not a vector type, it's a float type, and I'm going to call that my, actually, there, my shadow matte. Now, render. And so now if you go, you select the shadow matte AOV, you have nothing, but don't forget that we need to display now the color, and then you have your information inside the AOV of the shadow matte. Now, another pass that we can create to help the compositor, because I've seen some compositors using this, is a 3-point lighting with RG and B value. And this often helps them relighting the smoke in compositing. So for that, I'm going to create a new pass here that I'm going to take off the dust. Okay, so I'm going to base my new pass of the dust pass that we have before. And I'm going to call that dust tech, okay, for technical pass. Here, I'm going to use exactly the same and probably the same parameters as well in terms of quality. So maybe you also want to do action, what is it? Yeah, action, create a reference copy so you can have exactly the same values as the dust here. Okay, let me check, let me show you. Here we have everything which is copied, all right? And now you can go here and kill the slides. And then for each parameter we are going to change, you can disconnect the channel and then put your own values in there that will be separated for the dust technical pass. And so now I have this, I want to add some lights, and I prepared them for you here. So that's tech light R, G, and B. Each light is going with a color red here. Here we have green, and here we have blue color. Okay, and each of them, if we look at them, they are at the origin, and they are oriented in such a way that the red light is in the X direction. Okay, the Z light is in the Z direction. The blue light is in the Z direction, and obviously the green light is in the Y direction. And they are facing the negative direction of X, Y, and Z. Okay, so the X axis is going this way, so the red light is lighting this way. So we have the positive value on this side of the axis. Same goes for the Z-axis and the blue light, and same goes for the green axis, green light, and the Y-axis. So once we have this light, come back to the ROP, and here we are going to add the tech light. So tech light, and I'm going to do a star. So now I have this. And now we have this, then we can go to the render view, select the dust tech, and hit render. And so this is what the render looks like. Now we can go here to the different AOVs, and we can see that we have our different lights. Here, if we increase it, we can see also that it's coming from the Z direction here. The green light here is coming from the top, so that's good. And then here, the red light is coming from the X direction, which is almost aligned with the camera. So we see almost everything from the dust. One thing you may have noticed is that this color pass here is taking the color from the shading as well. Okay, here the shader that we have on the dust object. And we want to avoid that for tech pass. So I'm going to create a geometry here. Okay, and I'm going to call that dust tech. And inside here, I'm going to merge, object merge, sorry, the output from my dust, and I want to output the render. Okay, so that way I know that it's exactly the same as what I have here, what is rendered here. And so here I'm going to do merge dust, and I'm going to put a render flag just here, just in case, to be clean. And then I go up, and here inside the material, I'm going to use a shader, material shader, and I'm going to use something which is exactly the same as dust, except that I'm going to change the color here to 1, 1, and 1, so that's completely white. And I'm going to call that dust tech. then go back here to dust tech and then assign the material dust tech, and that's good. And then you go to your dust tech pass here, and inside the object you need to break this and select the tech object. And now if you go here, go for dust tech again and render. Now, obviously, this is a little too bright here. And so go back to the shader here and bring that back to 1. And now this is the render. And it's a much better range of values because we don't have any values that are burnt out. Now, I don't know if you noticed, but we don't have any shadows there. And this is because I forgot to mention one thing. Here on the tech lights, in the shadow, I use the shadow mask with dust. Okay, I want only the shadow from the dust onto itself. And because now I change to dust tech, then I need to change the name as well here to dust tech. Okay. And so this is what we have now. Okay, so we got back some shadows and now you have some variations in there. And if you look at the red light, this is what we have. If we look at the green light, the one coming from the top, then you can see that we have the direction of the light, which is correct, okay, compared to before. And then if you look at the B light, we see that it's also coming from this direction, and we have more information because we have now some shadows, okay. Now, obviously, we need to improve the quality of the render, especially here in the transparency part, but that you know how to do that. Now, obviously, you can still tweak your render here by playing with the shadow or by playing with the lights and the shadow tab here. Mainly, my recommendation is not to have shadows going all the way down to 0, okay? Try to have an interesting range of values because this is a technical pass and this is going to help the compositor on the shot. Also, you can play with the density to have some more bright values on the top. So let's say here you want some more green, but then you want some shadows going progressively all the way to black. You might want to play with the density scale and the shadow density. And last advice, in any case, you should talk to the compositor of the shot, okay? He's the one who can tell you what he needs to be able to use your pass. So go and talk to him. Does he need more density, less density, more shadow, brighter or not? So you have to go and talk to him to know exactly what he needs. Now, there is another configuration you might want to consider for the lights. So just let me hide this. If you go here, you can parent them all to the same null, okay? And that way, obviously, the lights, and if you go here, they are at the origin, the lights can be modified all together, okay? And then you might want to parent this null to the camera. And so if we go, so I select the lights, you see that now the camera are parented to the lights are parented to the camera. And if we look at them, so the blue light, which was aligned to the Z-axis, is now aligned to the camera axis. Okay, so this is really the front light. And then here the green light is still the top light. Okay, so it's it's there, it's lighting from the top. And then we have the red light, which is lighting from the right towards the left. Okay, and so if now I go to my render and I do a new render, this is what we have now. Okay, and so now if we compare the lighting, this is the red light, and it used to be like this. Okay, now this is the green light coming from the top still, but with a different angle. Okay, it has the angle of the camera. And now this is the blue light, and now it's just coming from the front of the camera. All right, so really talk to the compositor in charge of the shot so that you know exactly what he needs. Maybe this won't work if you have a moving camera. Okay, you might not want to parent that to a camera which is animated, because the lighting would change constantly, and maybe this would not be appropriate for the compositor. It would make his life harder. So the best is really to talk to him and see what configuration he would like. And then you have another pass, which is interesting. It's rarely used, though sometimes I've seen some people using it, is the velocity pass. And so to have the velocity exported to an AOV, you first have to go to the shader and get the information into the proper vex variable. So go inside the pyro shader, okay? But because it's locked, you have to first unlock it, then go inside. And then what I do, I usually put my exports here towards the end. Now I'm going to do a bind because I want to get the velocity here. Okay, so I'm getting the velocity, which is direction vector, okay? And then I want to output two things, so bind export. I'm going to output vel as world, okay, into the world coordinates. And then here I'm going to export velocity into the camera coordinates, okay? And so here I'm going to say $OS, and that way it uses immediately the name that I give here. All right, both are direction vectors. Okay, and then so it's going to use this and this one here as well. But you see that I want them in two different coordinate systems, and so I'm going to use the transform. This one here, I'm going to say, okay, my velocity when it's in the simulation, it's in world space, so I force that to world space, and I want to convert it to world space. So I want to keep it in the same space. Okay, I do that just in case. I don't want it to be changed into camera space or anything without me wanting. So this one is forced to the world space, and here I'm going to do the same transform, but instead of changing to world space, what I'm going to do here is a camera space. All right, so now, sorry, we have, sorry, we have those two outputs here. So we have those variables available. And then I can go to my dust text shader, and I can go to the image, extra image plane, and I'm going to add a new one here, which I'm going to call, so I'm going to bring the variable vel world, all right, and I'm going to output that to vel world, and it's a vector type, that's good. And then I'm going to grab a new one, vel camera, I think I named it, and then vel camera. Okay, let me just double check that. Vel camera, okay, that's good. And so here I have a vector type, which is good. And so we can now go here and test the render. And so let's check the vel world. Okay, this is what we have here, and this is what we have for the camera. Apparently something is wrong here, I can tell, because we have absolutely nothing here, okay? And if you go here to the transform, you see that we didn't change this. This is really important. We are not changing a position here, we are changing a direction vector. And you need to set it. If you forget to set this, you will have problems and you will have the wrong information, okay? So make sure you have a direction vector all the way down to the output of the vex variable. And now we have the correct information inside the vel camera pass, okay, the AOV. And if we check the vel world, this is what we have now, okay? Of course, you have some black values somewhere, like here. It's because the velocity can be negative, so it's going away or left or right or top, bottom. You might have different signs, and you cannot define this. You cannot display this into the color, but it should be correct. Okay, good. Now, obviously, if we look at the velocity, either from the camera or from the world, we have a lot of noise here. Keep in mind that this is a volume we are talking about, okay? So the rays are going through the volume, and it's sampling the velocity information at different points inside the volume, okay? And so the velocity that we see here is the result of all the velocity that we are seeing through the volume. So the more transparent the volume, the less precise might be the velocity, okay? You get the entire velocity range from there all the way to the background of the volume, okay? And same here and same here, same everywhere. You have all the velocity stacked up and rendered into this pixel, okay? So this is something to keep in mind. It's not the exact velocity from the voxel which is in front of the camera, the first voxel that is hit with a ray, okay? It's the entire range of all the voxels that the ray is actually marching through, okay? So it's not precise, but it's sometimes quite useful if you want to do some post rendering motion blur in compositing, and sometimes it can give a good result. And one last thing regarding the velocity AOVs. If you export the velocity into an AOV, it's usually because you want to do motion blur into compositing. If you want to do motion blur into compositing, that means you don't want the motion blur onto the image. Okay, so you should break here the connection with the original dust shader, and you should deactivate this. The problem is if you deactivate this, then the motion blur is not going to be calculated at all. That means the velocity as well won't be updated, and you might have some problems inside the shader to get the proper velocity. So you need to activate it, but here you have to uncheck allow image motion blur. That way, if you look here, that way you have the velocity, but you don't have it blurred. You don't have the image blurred during the render. Also, don't forget that on the object here, you have to select the velocity blur for the motion blur. Okay, so two things. Here you activate the velocity blur on the object, and then you go on, no, not on the shader, sorry, on the mantra pass, you activate the motion blur, but you deactivate the image motion blur. Just one thing about the P-pass. P-pass, you can express it into camera or world, or at least I did this too here. The main difference was the transform that we change it from current to camera, and it's a position, okay? Don't forget that. It's not a direction like this, it's a position. Same here, but this one from current to world, okay? And this is what I have, P world and P camera. Obviously, to find the values and to get some the range, you can see it by reducing the amplitude here of the brightness. And same here, you go to the world and you can see the variations by reducing the brightness. Now, you see how much noise it is. P for volume, it doesn't represent much thing, okay? It's the same reason as for the velocity. We are going through a volume, we are marching, the rays are marching through a volume. So the position you see here is the result, the average of all the sampling that we've done through the volume. So it doesn't mean much thing, okay? Maybe the P camera, you can get this coordinate here with the axis, and it's like positive towards this side, negative towards this side. Maybe you can get something out of it. But I wouldn't really rely on this. So if the compositor asks you for this pass, just, I mean, at least you know how to do it. But I didn't see it much used. Now, one case when it can be used is if you have some really opaque, dense volume. And because it's dense, the ray is not going through the volume all the way down behind it. You just have the front of the volume. That might make some sense to get the position. Otherwise, P, the normal, the velocity, all this information are quite unprecise, not really relevant for volumes, okay? So if you have transparent volume, not relevant, but if you want them, at least you know how to do that. For opaque and really dense volume, this could make sense. Now, still about the AOVs, I prepared this scene, class 15 AOVs. This is some basic setup with a sphere at the origin, which I convert to a volume. Let me show you that. Here I convert this sphere, so I put some velocity on it, and then I convert it to a volume with a velocity field. So you have this here with density and velocity as VDBs, and as an option, you have also the possibility to use a volume there to render. And on this, I set a pyro shader, and inside the pyro shader, I have here the final AOVs I want for the velocity and for the position. This is kind of a reminder, a cheat sheet for me, because I have a hard time remembering what is good here. So I defined this, the word, the cam, the NDC also, so you can have it as well. I rarely use this one, but just in case you know it's there. And so when you do a render here, you have the vcam, vworld, so you can check them, and you can actually check the values here. So for instance, here, if I go back to my sphere and I display this, so I get the velocity here, okay, and then I go back here. So if we look here, this is supposed to be v world, and we look at the values there, and we have 2.8, minus 2.8, and 0. And so it's x, y, and z. And this is what I define here. Not precisely, because the velocity is 1 and minus 1. Okay, so it's 1 in x and minus 1 in y. But remember, everything is multiplied by the density, and you have an accumulation of the velocity. So this is an example of the velocities are not precise and not really correct, but at least you get an indication of what you have. So then you have in comp, they can maybe scale it or whatever. But at least I know that the transform here is correct because I have the proper value. And then if I go to the vcam, this is what I have. I have, well, let's go here. I have 3, minus 5, and 3.9, which is 4. So that means if I look through my camera, which is, where's my camera? My camera is somewhere here. Okay, good. So if I look through my camera here, I can see that I have some velocity in x, okay? So in this direction, I have some velocity in y, minus y in this direction, and it's also going away from the camera. And that's why I have some positive z, okay? Remember, z goes increasing in this direction, so we have positive z. And in this direction is negative, okay? So here I can tell that the values are correct, and that's why here I know this vcam transformation is correct. And then if I look at the p world, this is what I have. So let's look at the different paths. So we have the red, okay? If we look from the camera, obviously the x is white here because we have positive x, and then here negative x in the world coordinate, okay? So this is why we have this, the half of the sphere is here. And then if we look at the green one, then we have positive values above, and below the plane we have negative values. And here this is the z-axis, and the z-axis, if we look here, we have actually something going, when the half of the sphere is here, so the positive values are here, and here we have negative values, which is what we have here. And now if we look in the pcam, this is the position in the camera space. This is what we have. So x, okay, positive, negative. Sorry, I'm going to remove this. Positive here, negative here. Y, positive here, negative here. And here the blue is the z. And so the z, if you reduce this, you have an accumulation of position, which is, again, not really precise. Okay, and this is my cheat sheet, so I know that the transforms are correct. So you can use this setup and tweak it, play with it, and can refer to it in case you have any doubts on this. Well, this is the end of class 15, in which we've seen how to add technical passes and AOVs to our renders. Just remember one thing is, because this is volumes we are talking about and not hard surface, the values you have per pixel is not necessarily correct, okay? That is due to the remarching. We are accumulating values of the entire volume here. All the samples that we do when remarching the volumes are actually accumulated, and the value of the position we have in the AOV or the velocity are not necessarily precise. Some people can do great magic with it, so it's good. You can export them for compositing. But just remember that this is to handle with care, and always check with your compositor that he has what he needs, okay? And the values that you are giving him are actually useful for him. All right. And well, thank you for watching, and I'll see you in the next class. Goodbye.